Hi everyone. We're going to do one more example where we need to graph a trigonometric function, this one here, using horizontal translation. And how I know that the method of horizontal translation can be used here is because of this number, pi over 3, that's being subtracted inside the parentheses, inside the sine function, or I can say right next to x. We start by graphing the basic function, the one that does not have minus pi over 3, so it's just negative 3 sine of 4 over 3x. Let's collect all the important information that we need for graphing purposes. The amplitude of the graph is going to be 3. The graph will be reflected because I can see a negative sign in the front. The frequency of the graph is 4 over 3, that's the coefficient of x. And to find the period, I'm going to take 2 pi and divide by the frequency, 4 over 3. So that's 2 pi over 1 times 3 over 4. That is 3 pi over 2. So let's graph. I'm going to place 3 pi over 2 on the horizontal axis. That's where the first cycle ends. I'm going to split the segment into 4 equal parts. To label the first one, I'm going to take the period, 3 pi over 2, and multiply by 1 over 4, since it represents the 1/4 of the period. That's 3 pi over 8. And as I keep adding 3 pi over 8, I'm going to obtain the rest of the labels. 3 pi over 8 plus 3 pi over 8 is 6 pi over 8. Another 3 pi over 8 gives me 9 pi over 8. And then 12 pi over 8. If I divide out 4, I'm going to get 3 pi over 2, so that checks. Now 6 pi over 8 simplifies to 3 pi over 4, and 9 pi over 8, that's the simplest form. So this is how we're going to label the horizontal axis, and at each of these x values, the basic graph is going to have one of the key points. We can erase the scratch work. Now I'm going to label the vertical axis. Since amplitude is 3, I need to label it up to 3 and down to negative 3. Let's start plotting points. We're dealing with the reflected sine function. The sine function, no matter if it's reflected or not, it starts at the origin. After the 0 point, it goes down to the minimum. So it's decreasing after that. Here I'm going to have the minimum point. Then it goes back up to the 0, then maximum point, and then back to 0. Now I'm going to connect the points. Okay, so here I have one cycle of the basic function, y equals negative 3 sine of 4 over 3x. And that's the one that we're going to shift. And that's the reason I graphed it lightly, since it's not the final answer. To find out how far and which direction to shift it, we're going to perform step 2. To determine the phase shift, we need to take the entire expression that sits inside the parentheses, set it equal to 0, and solve for x. So I need to solve 4 over 3x minus pi over 3 equals 0. To isolate x, first I'm going to add pi over 3 to each side of this equation. That gives me 4 over 3x equals pi over 3. And now to get rid of 4 over 3 in front of x, I'm going to multiply by the reciprocal, 3 over 4 on the left, and then times 3 over 4 on the right. The product of reciprocals gives me 1, so it's just x on the left-hand side, and pi over 4 on the right-hand side. What this means is that we will have to shift the graph pi over 4 units to the right. And it's to the right because the result is positive. Also, you might remember that the direction of the shift, the direction of the horizontal shift, it's always opposite to the sign that we have here inside the parentheses. Now to find out the new location of the key points after the shift, I'm going to perform step 3. First, I'm going to list the original x values of the key points. These are those 5 key points within one cycle. So there's 0, 3 pi over 8, 3 pi over 4, 9 pi over 8, and 3 pi over 2. And to find new or shifted x values of the key points, I'm going to take the original values and add pi over 4, because remember, that's the phase shift that we found in step 2. So the first point will be add pi over 4. The second one, I'm going to have to create same denominators, so it's 3 pi plus 2 pi, 5 pi over 8. This is 4 pi over 4, or pi. Point number 4 is 11 pi over 8. And point number 5, okay, it's 6 pi plus pi, 7 pi over 4. So I determined the x values of the key points after the shift. And now I have to place them on the horizontal axis. The problem is that I'm still not sure where exactly they're going to fall. Where is 5 pi over 8? Where is pi on this number line? Since I'm dealing with fractions here, and it's hard to see how they're related, what we need to do is to write all these fractions with the same denominator. And after that, it's going to be easy to compare them. If we look at all the denominators presented in the given fractions, 8, 4, 8, 2, 4, 8, 1, 8, 4. Okay, so we basically have to find the LCD. So it's going to be denominator 8. Let's adjust all fractions so they have denominator 8, and that's going to be my scratch word, so I'm going to erase it later. Now the shifted values will look like this. 2 pi over 8 for the first point, second point is already with denominator 8, third one is 8 pi over 8, then 11 pi over 8, and 14 pi over 8. And then on the number line, 3 pi over 4 I'm going to note as 6 pi over 8, and then 3 pi over 2, that is times 4, 12 pi over 8. And now we're ready to place the shifted values. Notice that the first point, oh, it's this 0, will be shifted to, well, it's pi over 4, but we're going to look at it as 2 pi over 8. Right now it's here, it's going to be shifted to 2 pi over 8. Now, where is 2 pi over 8? Well, if this is 3 pi over 8, 2 pi over 8 will be a little bit to the left, right? In my mind, I can split this segment into 3 parts. It's going to be 1 pi over 8, 2 pi over 8, and then 3 pi over 8. So I would say it's here. But I'm not going to write 2 pi over 8. I want to use simplified fractions. So I'm going to put pi over 4 instead. They are equivalent after all. Next one that I need to place is 5 pi over 8. Okay, well, if this is 3 pi over 8 and this is 6 pi over 8, then 5 pi over 8 will be closer to 6 pi over 8, right? So, and I can use the same trick. I can split this segment into 3 parts. So it's 3 pi over 8, 4 pi over 8, 5 pi over 8, and then 6 pi over 8. So same kind of pattern. That's where I'll place 5 pi over 8. And once I determine the pattern where all new shifted x values are placed, I can simply add the other 3. 8 pi over 8, or just pi, will be here. 11 pi over 8 will be here, close to 12 pi over 8. And then 14 pi over 8, here I can just approximate its position. It's right here, but I'm going to write it as 7 pi over 4, this way. So we found where we need to shift each key value of the basic graph, so I can erase all the scratch work. And I'm ready to shift the points. So the first 0 will be shifted to pi over 4. Minimum point will be shifted to 5 pi over 8. Next 0 will be shifted to pi. Maximum point will be shifted to 11 pi over 8. And then the last 0 is shifted to 7 pi over 4. Now I connect those points to obtain the graph. Okay, so here it is. What I have in red is the final answer, and that's the graph of the function y equals negative 3 sine of 4 over 3x minus pi over 3. Oh, and by the way, here's step 4 that I mentioned, but I didn't write it. Here it is.